Mr. Henrichs holds a master degree in brewery and beverage sciences from the Technical University of Munich, and will talk now about real-time quality analysis for traceable and sustainable food supply. I'm really looking forward to this talk, and the floor is yours.
Thank you, Professor Schmid. Dear ladies and gentlemen, have a good morning. My name is Henrichs, and I work as research assistant and PhD student at the Department of Food Informatics at the University of Hohenheim. And today I want to briefly introduce you our ideas on how to enable real-time quality analysis for a sustainable and traceable food supply. And before I start, I want to provide you a short introduction to our department. We are quite new. And the University of Hohenheim has a big tradition, as some of you might know, in food, nutrition, agricultural sciences. And since its foundation, the university has continuously developing and evolving and keeping up with time. So digitalization became more and more important in the food industry, and even the University of Hohenheim recognized this, so it founded the Department of Food Informatics in 2020. And this growing impact and importance of the digitalization was also revealed by a study conducted by Germany's Digital Association, Bitcoin, and the German Federation for German Food and Drink Industries. And first of all, most important point was they see digitalization as a big trend. They further revealed a lot of future trends, including the real-time production, the production of personalized food, the traceability from farm to fork, and intelligent packaging, as we already heard today. But they also revealed some issues, and the biggest issue is that the employees mostly lack in IT skills. And this is the aim of our department, the Department of Food Informatics, to combine all these aims. So you still might wonder what actually means food informatics. And we define food informatics at the interdisciplinary operation at the interface of food science, biotechnology, and the computer science. So we combine all these different scientific fields, and we try to improve the whole food industry with digitalization using artificial intelligence, IoT, Internet of Things, predictive data analysis, and also artificial intelligence. I think I already mentioned this. So we try to combine this, and we cover the whole food supply chain, from the primary production to the consumer, and also consider traders and logistics. So in this talk, I want to provide you an idea on how to enable a real-time quality analysis. And therefore, we first need to define and understand our problem. So, seeing the food supply chain, we consider all stages or steps of a food product, from the primary production, which is usually a farmer, to the consumer. And as some of you might know, there also exists a lot of circular flows, but in this talk we want to keep it a little bit simpler and focus on the straightforward and linear food supply chain. Within this food supply chain and in between these steps, there's a lot of paperwork done, and of course there is some digitalization already applied in the food industry, but the data is often not shared and only stored in single data silos in the cloud. We further want to focus on the food quality, and considering the food quality, the quality will be mainly gets analyzed at the manufacturer side. Of course, the farmer and the supplier will verify the food quality as well, but as a manufacturer, we process the foods and adjust lastly the quality parameters. And afterwards, the food is expected to stay stable until the end of shelf life, or a little bit further until the consumption. So the next quality control will take place at the consumer. And if the food is good, the consumer will be happy and he will enjoy the food. But if there something went wrong in the food supply chain and the food is not that good anymore, is spoiled or damaged in another way, the consumer won't be happy. So what the consumer will do is he will contact the retailer and the processor and complain about the food quality. And the retailer and processor has to go step by step through the whole supply chain and find the point of error. So, as you might imagine, this is really time-consuming, it's really expensive. They are always depending on the other actors and the information provided by them to find this point of error and avoid this point in future. To provide a better understandability for you, I want to briefly introduce you some common terms from the computer science. First, the Internet of Things means devices of our daily life, actually the so-called things, which could be watches, cars, or even production systems in the food industry. And those are production machines. And these devices are connected with sensors. Additionally, sometimes they already have some computers applied and transfer the data to the cloud. So in the cloud, we have remote servers which have a huge computational capacity, much more than your home PCs. And these enable complex calculations to be done in less time and fewer time than at home. So, for example, considering your dynamic route planning system in your car, when the system recognizes a lot of devices to be located in the same region, going with the same slow speed, the data will be transferred to the cloud, and in the cloud the system will recognize a traffic jam. Afterwards, the system will start replanning your traffic or route and transfer the information back to your device. This cloud computing paradigm works quite well, but in the last years, the amount of devices and hence the amount of data has grown fast. Additionally, the devices became much more powerful. So the calculations don't need to be done in the cloud anymore, and we can do this in a layer between, the so-called edge. And in the edge, when you think about smartwatches, a couple of years ago, smartwatches always had to be connected to your smartphone or mobile phone. Nowadays, they are also able to operate without them. This means that the analysis of the data will be done much faster. We can further reduce the amount of data which needs to be transferred. Since we nowadays share only the models itself and not all of your data, which means also that we can protect your personal preferences to be shared via the cloud. Some examples, as I already said, data processing can be done on the edge, and we share only the models to influence our decisions and connect different systems. It enables the industrial IoT, the industrial Internet of Things, which means we have now smart and intelligent production systems. And another example is augmented reality, where we include virtual objects in our visible field or site. And this all means edge computing. So the question might be, how is this related actually to the food industry? In the previous talk, we already heard about intelligent packaging, so I want to briefly provide a short recap. Basically, we distinguish between indicators and sensors. So the indicators indicate a presence or absence of a substance or the extent of reactions. For example, we have here the indicator on a packaged meat, and if the meat starts to spoil, it releases spoilage gases, which leads to a change of the color of the indicator. And after this, we can easily determine some kind of the quality of the meat or the freshness. And this works quite well. We are already able to determine the quality in a way, but this data is not really processable, and we only can react to the conditions already exposed to the package. So we also consider sensors, because sensors quantify the measurements and transfer these measurements into electronic signals, which can afterwards be processed. This works, for example, with this NFC tag or this sensor on the left. It's a printed sensor on paper, so it's near zero cost. It's equipped or connected to an NFC tag, and you can easily read the data with any NFC reader, for example, your smartphone. So with the help of these sensors, we can already monitor the current condition of the food. And we can afterwards take this data and transfer it to a cloud to process it further. But the cloud has some more issues. You have sometimes maybe heard about latency or communication issues. So the predictions or the analysis is then more like a retrospective analysis. And what we want is a real-time analysis. So we transfer the data to the edge and edge servers and analyze the data there. We analyze the data directly and provide the answer or the condition, the quality of the food directly to the user, depending on the system, for example, as already heard, with your mobile devices or smartphones. And if the food is damaged in any way or spoiled or something else, it should be easily identified and removed from the supply chain so it doesn't get consumed anymore. And it would be even better if we are able to predict future states so we can avoid these critical conditions and avoid the food waste in the end. The question still is, how can we share the data in a secure way? And this could be done, for example, using the blockchain technology. Some of you might know the blockchain from cryptocurrencies like Bitcoin, and you can imagine the blockchain as distributed ledger between all the actors. So every participant in the food supply chain and every participant in the blockchain stores a minor amount of the whole data, basically its own data. And this data is getting logged and validated with so-called hash functions, so the data inside the blockchain is not manipulable anymore. Blockchain is already applied in some cases in the food industry, and as you can see, those are all used for transparency reasons. Until now, more for the traceability or tracking of your food items, so where does the food come from, but it's also possible to use this to provide the real analysis or information of the analysis of your food. How does it work? Every consumer or other actor in the food supply chain can easily access the data. There are some examples using QR codes. You can scan them and access the data in the blockchain. So far, I talked about the technical requirements for this enabling of a real-time quality analysis. In the next couple of minutes, I want to provide you a short overview on how we can use the data and process the data using digital twins. Digital twin is a concept where we create digital representations of physical objects, machines, services, or anything else you can imagine. And these digital representations behave the same, they have the same conditions and properties as the physical objects. So we do not only have simple models, we have complete simulations which react the same when exposed to external influences. And if you think of machines, this would be maybe some kind of quite easy. The machines work in a well-defined way, have well-defined and specified movements, rotating, robot arms, and so on. But considering food, it becomes a little bit more complex because in food we have a lot of chemical, physical, and biological processes which are also connected to each other and influenced by their own. Digital twins, in combination with machine learning, are able to process these interconnected processes and can simulate this quite well. So this enables us already a better monitoring and quality analysis of our food items. For example, we can model fruits or vegetables and take a deeper look inside them without cutting them. We are also able to predict some parts with a digital twin. For example, when you consider that you change your recipe of your food product, digital twins are able to simulate the product in the future, so how it will taste, smell, and look around. Digital twins are already finding slowly their way into the food industry, and last year we conducted a study on this, reviewing 38 publications from science and industry. And one of the questions was, where are digital twins applied in the food industry? So referring back to our food supply chain, they are mainly located in the production or primary production and in the processing stages. Those digital twins there in the stages were mainly used for monitoring and control of machines or whole production systems. Interestingly, the digital twins that we found in the supply or distribution stage and in the retail stage was focused on the food product itself. So it provided a quality analysis of the food products and were further determining the remaining shelf life of our foods. As we already heard, this is quite interesting to reduce the amount of food waste. So another question was, what were the digital twins actually used for? And nearly all of them, so we had 51 digital twins in total analyzed, nearly all of them were used for monitoring, which seems to be quite logical, because we are always interested in taking a deeper look into our products and our machines and so on. And a lot of them also provided some predictions or have some predictions calculated. But these predictions were only rarely used for optimizing the whole systems or optimizing the food supply chain. And also it might be quite easy to see the influence of our processes on the food product itself. It is also interesting to consider the food product and the behavior of the food product itself. And this is where our research starts. So to summarize my talk, I provided you a short overview of the smart and digitized food supply chain, containing smart sensors and intelligent packaging to monitor the food conditions, the machine learning on the edge to provide a data analysis and process the data, and the blockchain technologies to share our information. I further introduced you the concept of digital twins, which enables us a much deeper look inside the products, machines, and all of our twinning concepts. And if you are interested in our work, I invite you to take a look at our website, which you can get over this QR code. You can further send us an email, and me and my colleagues, Christine Borsum and Julia Senge, who are always also here, we are happy to answer your questions now or after the session. Thank you for your attention.
Thank you very much, Mr. Henrichs. Very interesting presentation. And now we are curious to hear if there are some questions and remarks. And here we have the first one.
It's the first time I hear this notion of digital twin, and I wanted to ask if we can just have some examples. Allow me a second question. Is predictive modeling also a digital twin?
Okay. I will repeat the question again. She heard this term digital twin for the first time, and she is asking if you could name a few examples of digital twin.
Of course. So related to a food product, for example, we reviewed a paper and they were twinning a mango to get more information about the temperature during the transport processes or transport stages. So what they have done is they produced some kind of a physical twin first, so an artificial mango equipped with a lot of sensors, and then placed it into a transport packaging with all the other mangoes. And with these data gathered in the physical mango, they were able to create a digital twin and to analyze the temperature within the pulp of the mango. And then they were able to further process the data and calculate the amount of quality they could have lost during the transport to expose of higher temperatures. So it's nearly possible to imagine everything you are able to and create a physical twin maybe, and afterwards a digital representation to get a deeper insight. I hope this answers your question.
That was the first question. There was a second question, which I thought I put the two questions in two parts. The second question was the term predictive models. If a predictive model is equal a digital twin, and or not? How could you?
So, if I understand the question correctly, we can have a digital twin, and we usually say we feed the digital twin with more or less real-world data. But we are then able, with a lot of calculations and equations which are commonly known, to predict the future states of this model. So, when, for example, considering again the mango, we can calculate the inner pulp temperature of a mango when the outer temperature increases a lot. And so this could be done with the predictive.
So the digital twin is the food product itself, and the predictive modeling is like predicting the shelf life depending on the processing.
Exactly.
So, okay, perfect. Okay, great. Are there any more questions? We are really good in time, so feel free to ask questions and make comments. Thank you. Yeah.
Well, I missed one part of the presentation. I want to see how we can any thought about integrating the fact that you have events and digital identity into reducing the food waste.
Okay, I will try to transfer that question. The question was if you could give some examples or identify how the events along the added value chain could be integrated in the model in order to prevent food waste. How does that work?
So basically, again, when considering the mango, when we cannot keep the transport temperatures or storage temperatures, the quality of the mango will decrease. So it will start some biological processes inside, and we have a quality loss. So the idea is to prevent this by considering all actions along the food supply chain. We have the transport from the central storage to the retailer. And we see that in the next few days we will have really high temperatures outside. We are, for example, having summer up to 35, 40 degrees. We can then calculate and predict the future states of the mango and predict then if it's intelligent to supply the food products, for example, at noon, or if it's better to do this in the evening. And this would be some recommendations we would then provide on these predictions made from the digital twin.
Okay, thank you very much. Are there any more questions on that session? Yep, certainly. No problem. So the fourth question will cost some money, but 3 is fine. No.
In the beginning, there was the notion that they are trying to actually get the normal people closer to using the technology. Easy to apply, and I was asking if we can also have some examples of how this is done.
That the consumers are using these technologies.
Only the consumers. I think it was more on the people involved in the process.
Exactly. Okay. This question is about your study. Congratulations on that. It was published quite recently, I saw.
24th of December last year.
Okay, so. Perfect. So quite recent study. And one question was, do you have an idea why these predictive models or digital twins, which are used very, very often in the processing stage, why this is not used at the consumer level? It's rather used at the processing stage for monitoring, as you explained, but I think you mentioned only that there was only one study where at the consumer stage or later, not in the process.
So the study or the paper we found concerning the consumer stage was basically a digital twin model of the consumer itself. And this model was used to create personalized food for the consumers. And it's quite difficult to model the consumers. and to model their behaviors and to capture all their facets. So there has to be a lot of research done in the future, and I think this is why the amount of the machines is, or the digital twins for the machines is much higher, since the processes are more well defined and we have a better understanding of the movements and of the parameters of the machines.